Hello, we are Synergy Creative, and this is our proposal to help create a regenerative future for the city of Nolanville.
We'll cover our presentation with 5 sections: background and our team initiatives, analysis, design drivers, which includes environmental performance, connectivity, smart technology, character, and phasing build-out, our design proposal, and the design timeline. Our team addresses 3 main project challenges: environment, communication, and connection. We face these challenges through 3 elemental conceptual building blocks: earth, water, and matter. With these overarching concepts, we provide 2 main goals for the future of Nolanville that not only align with providing solutions to the project challenges, but establish the value of our 3 building blocks within city structure.
Our mission statement for this project is to reimagine Nolanville's development in order to provide the city with restorative, educational, economic, community-minded, and productive spaces through the 3 essential building blocks of earth, matter, and water.
As we visited the site, we assessed many variable elements that gave context to our chosen challenges. First, the natural systems. The physical context, character, land use and zoning. An important finding was the lack of public green space and parks. Our first design proposal is a living lab for smart tech startups and sustainable practices. The location is a 107-acre site south of Highway 190.
Our goals for the Living Lab are: first, to provide a research incubator and educational site to not only promote the city's Smart Town campaign, but also to help be a leader for smart technology in the United States. Second, to bring economic opportunity through emerging technology. Third, to support the local ecologies. Fourth, to provide a space for all residents of the community to visit and get involved. Fifth, to showcase cutting-edge smart solutions that engage the small town with new, sustainable, and smart design methods. And sixth, to create educational opportunities for the city of Nolanville and all who come to visit the Living Lab.
We divided the site into 4 parts, and we maintain the existing ownership in the westernmost portion of the lot. A 20-acre portion will also be left to the existing ownership, but this part will serve as an area of land for rotational grazing, which is a cycle of rotating grazing species to naturally maintain the land. A pedestrian and bicycle trail meanders through the site from downtown Nolanville, and it connects to a larger trail system in future development, which we'll talk about more later on in the presentation. The last portion of the site, about 45 acres, will be designated for the Living Lab Center. The idea for the Living Lab works to synergize all of our conceptual building blocks, earth, water, and matter, by featuring various smart and sustainable methods from each of those focus areas.
On this slide, this is our proposed Living Lab concept for the city of Nolanville. On this slide, this is our proposed Living Lab concept for the city of Nolanville.
This is an example of a trifold brochure that a guest would be handed upon entering the Living Lab. It lists the different aspects of the site on the left and contains the corresponding map that guides guests through the site.
Unfortunately, the site is polluted by noise from the adjacent freeway, and as a solution, we utilize strategically placed mounds of earth to distribute and displace the noise.
In the plaza, one can experience several smart implementations. Some of the implementations one can experience is a piece of art that changes color with a push of a button that is powered by solar panels and kinetic energy pavers, irrigation system that uses recycled rainwater, a public bathroom for guests which sewer companies can manage using a water savings touchscreen technology panel, and in the back next to the bathroom, there is a room that serves as a fiber internet room. In that room, one can see and access network gear that powers the internet connection throughout the site.
One of the sustainable methods that's showcased at the Living Lab is the solar farm. And a lot of people think that the solar farm can be a waste of land, but it's actually a great space to simultaneously establish things like naturalized and native grasses as well as pollinator meadows. One of the sustainable methods that's showcased at the Living Lab is the solar farm. And a lot of people think that the solar farm can be a waste of land, but it's actually a great space to simultaneously establish things like naturalized and native grasses as well as pollinator meadows.
This rendering shows an example of how the hydroponic garden within the Living Lab could function. A portion of the plants grown in this area are grown without soil. Instead, the plants are grown using a water-based and nutrient-rich solution. Since there is no soil directly around the roots, the root system is supported using an inert medium such as perlite, rock wool, clay pellets, or peat moss. The basic premise behind hydroponics is to allow the plant's roots to come in direct contact with the nutrient solution while also having access to oxygen, which is essential for proper growth.
One of the sustainable methods that's showcased at the Living Lab is the solar farm. And a lot of people think that the solar farm can be a waste of land, but it's actually a great space to simultaneously establish things like naturalized and native grasses as well as pollinator meadows.
The question I'm sure you are all asking is, what is the benefit to hydroponic gardening? Well, when compared to traditional soil-grown crop production, hydroponics has the following advantages. First, up to 90% more efficient use of water. Second, production increases 3 to 10 times in the same amount of space. Third, many crops can be produced twice as fast in a well-managed hydroponic system. Fourth, decreasing the time between harvest and consumption increases the nutritional value of the end product. Fifth, indoor farming in a climate-controlled environment means farms can exist in a place where weather and soil conditions are usually not favorable for traditional food production. And sixth, no chemical weed or pest control products are needed when operating a hydroponic system. This rendering shows the view going in and out of the research center and leading into the hydroponic garden. This shows an inside view of one of the greenhouses that are a part of the research center. In this greenhouse, researchers can experiment with high-yield plant growing technologies such as phenotyping, smart greenhouse technology, and organic fertilization. With phenotyping, the crops themselves can be altered to produce higher yields. Plant breeding has been used to develop higher-yielding varieties of crops. By measuring the high-yielding phenotypes, or the plants with the greatest yields, and connecting this data to plant genetics, it is possible to significantly increase plant productivity by growing only the highest-yielding varieties. As for smart greenhouse technology, the glass roof panels of greenhouses can be engineered to effectively grow indoor crops and gather power from the sun at the same time. The special tinted glass that makes up the greenhouse can generate enough solar electricity to control greenhouse temperatures. This can lead to higher plant yields as well.
Our second main initiative is a future growth plan for Nolanville. Driven by our 3 elemental concepts, it includes a trail system, accessible waterfronts, and a redesigned plan for the downtown. Our first elemental concept, Earth. To increase green space throughout the city, we've developed a greenbelt plan that connects a series of walking and biking trail systems that align with Nolan Creek for a majority of the trails. It helps accomplish connectivity between the north and south portions of Nolanville that are currently fragmented by Highway 190. It helps restore suffering ecologies. It dedicates acreage to publicly accessible green space for future development of Nolanville. There are many different trailheads and designated access points that are placed throughout the various communities around Nolanville, and they're all easily accessible by walking or biking. We've thoughtfully designed a number of trail conditions that we expect to see along the greenbelt at various points, and they're all designed to cause as little disruption as possible to the current topographies, as well as require minimal maintenance. Additionally, a connecting feature of the trail system that we'll see later on in one of the final phasing plans will be a land bridge or an underpass that helps bridge the gap that the freeway currently creates between the north and south portions of Nolanville.
With the element of water, we have 3 main goals. First, we want to enact an active stormwater management system that would help Nolanville control the stormwater in the city and recycle it effectively in the future. Second, we want to create a blueway that makes Nolan Creek accessible to the public and promotes recreational activities. And third, We want to use water as a tool to mitigate noise pollution and to grow food. All of these goals could be accomplished with the implementation of the Living Lab, as well as with our long-term phasing plan for the city of Nolanville.
With the matter element, we wanted to give the residents of Nolanville a vibrant, walkable downtown using smart technology and connecting the Greenbelt and the Blueway. We wanted to support the local community and economy by giving the city a unique identity and also adding new buildings where locals can set up their own businesses and restaurants instead of having to go to other cities to get the same goods. With this setup, the city of Nolanville's income will increase, and thus the funds would help the city to become a new smart city.
Our design initiatives will be implemented in 5 phases going into the future. The first phase is the anchor phase. It focuses on using the Living Lab to anchor smart city implementation, growth, leadership, and awareness, and also set the precedents for utilization of smart practices for the city. Transform. This phase begins to transform the central areas like the downtown, primary neighborhoods for trail systems, and begins the development on accessible waterfront areas. Enhance. As resilient development patterns continue, this phase further brings enhancement to those primary areas for the trail systems, and it also sees the completion of the Blueway. Extend. This phase focuses on the development that continues to reach the further out residential communities of Nolanville. Connect. This last phase implements the final connection of the north and south portions by utilizing the land bridge or underpass that was previously mentioned to complete the citywide greenbelt. Our landscape architecture team's initiatives coordinate closely with the overall Endeavor team goals. Our Endeavor team is creating a machine learning interface for city officials, and these project proposals for future development are important aspects of that interface. Both current and future projects and plans will be accessible in the interface, allowing constant status updates of how the city is constantly reaching their goals. It also will include data that can be gathered from research at the Living Lab to contribute to the overall goal of smart technology and machine learning.
To summarize, our team addressed 3 main project challenges: environment, communication, and connection. We tackled these challenges through the 3 elemental building blocks of earth, water, and matter. With these concepts, we provided 2 main design ideas for the future of Nolanville: the Living Lab and the future build-out and restructuring of the city. These design ideas not only provided proper solutions to the project challenges, but also established the value of our 3 building blocks. We hope that these design ideas will help lead Nolanville into a prosperous and regenerative future. Thank you.